in section 8.4, we're going to learn how to solve polynomials that are in factored form. The only type of equations that you know how to solve right now are linear equations. Those are things that the highest power on the variable is 1. So what we need to be able to do is turn our polynomials into things that look linear. First thing I want to talk about, though, is the zero product property. And it says if you have two numbers multiplied together whose answer is 0, you know that A has to equal 0 or B has to equal 0. And we're going to use this property in order to solve our polynomial equations. For example, if I have 2x plus 1 times 3x minus 4 equals 0, and I'm asking you to solve this, well, I have two numbers. That number times this number equals 0, so I know the first one has to equal 0, or the second one has to equal 0. And I solve each of these linear equations. First step is to subtract 1 from both sides, and then divide by 2. First step here would be to add 4 to both sides, and then divide by 3. So I get one answer for each one of the linear terms that make up the product of factors. One thing I want to talk about is roots. The roots of a polynomial function are the zeros of the function, which means when I set each of my linear terms equal to 0, what answer do I get? These are also going to be our x-intercepts in chapter 9 when we go to graph these functions. So, roots, zeros, x-intercepts, and solutions all mean the same thing. Okay? So I'm going to do a couple more examples if it's already in factored form for you. Two x minus 6 and 3x plus 9 equals 0. I get 2x minus 6 is equal to 0. 3x plus 9 is equal to 0. Add 6. Divide by 2. Subtract 9. Divide by 3. My answers would be 3 and negative 3. You need to be able to start getting to the point where once you have it in factored form with a 0 on the other side, that you can immediately look at this and come up with the answers. By the end of the semester, this intermediate work, I expect you not to have to do that intermediate work step by step and be able to directly go from 2x minus 6 equals 0 to x equals 3, and 3x plus 9 equals 0 to x equals negative 3. So start practicing so that these intermediate steps start to drop out. I'm going to do one more example like this. X times 4x minus 3 equals 0. Well, I have x times this, so that means x is equal to 0. Or 4x minus 3 is equal to 0. Add 3. Divide by 4. So my answer is x equals 0 or x equals 3/4. So if it's already in factored form, all you do is you set each factor equal to 0, and you solve those associated linear equations. What you need to be able to do is start putting things into factored form, and in this section, the only thing that you're going to be able to do to put them in factored form is to factor out the greatest common monomial factors, and then be able to work with problems that you may have to solve. So I'm going to erase the board and then do some more examples. To factor out the greatest monomial, we want to find the greatest common factor of the numbers, and then the least power of each variable that appears in every single term. So if a variable only appears in one term but not the rest, I can't factor out any of those variables. So I'm going to work through 4 examples. These are homework problems out of the book, and they are on pages 520 and 521. First one is 19. So every one of these problems, I'm going to ask myself the same questions. What is the greatest common factor of the numbers? And what is the lowest power of each variable that appears? So what's the greatest common factor between 3 and 16? They have no common factors except for 1. And then what's the lowest power of the variables? Well, I have s to the 4th and s, so it would just be an s. So now that I've pulled out the common factor, I'm going to do the division problem. 3s to the 4th divided by s is 3s cubed. 16s divided by s is 16. And that would be factoring out the monomial s. For 21, greatest common factor between 7 and 35 is 7. And the lowest power of the variable that appears in all the terms is w squared. So now I do the division. 7 divided by 7 is 1. W to the 5th divided by w squared is w cubed. Negative 35 divided by 7 is negative 5. W squared divided by w squared is 1. And that would be my answer. For 41, greatest common factor between 8 and 6 is 2. The lowest amount of a's is a to the 1st. The lowest amount of b's is b to the 1st. So I'm going to divide each term by 2ab. 8 divided by 2 is 4. A squared divided by a is a. B divided by b is 1. Negative 6 divided by 2 is negative 3. A divided by a is 1. B squared divided by b is b. And I am done. When you get all done, the term that's left in the parentheses can't have any common factors other than 1 for the numbers, and the variables can only appear in one of the 2 terms. Last one. Common factors between 6, 21, and 15 are 3. And the lowest powers of q's are q squared. So divide everything by 3q squared. 6 divided by 3 is 2. Q to the 5th divided by q squared is q cubed. Negative 21 divided by 3 is negative 7. Q to the 4th divided by q squared is q squared. Negative 15 divided by 3 is negative 5. Q squared divided by q squared is 1. And that would be the answer. So notice I did not solve any of these, but this is just practice factoring out greatest monomial terms. Next, we're actually going to be factoring and solving some polynomial equations. In order to solve an equation, you want to get everything on one side of the equation with a 0 on the other side. So my first 2 examples are already set up that way. The last one, I'm going to have to move this 8m over to the other side. So for today's work, all you're going to do is factor out the greatest monomial factor, and then set each of your factors equal to 0 and solve. So greatest between 5 and 5 would be 5. Lowest power of w's would be to the first power. Divide each term by 5w. 5 divided by 5 is 1. W squared divided by w is w. Negative 5 divided by negative positive 5 is negative 1. W over W is 1. Set each of these factors equal to 0. So I get 5W equals 0, and W minus 1 equals 0. So W is equal to 0 or 1. For the next one, greatest common factor between 6 and 18 is 6. Lowest power of C that appears in both is C to the first. Divide everything by 6C. 18 divided by 6 is 3. C squared divided by C is C. 6 divided by 6 is 1. C divided by C is 1. Set each of these factors equal to 0. I get 6C equals 0, and 3C plus 1 equals 0. So the first one, C is 0. The second one, I get 3C is negative 1. Switch pins for you. Divide by 3, and I get C is equal to negative 1/3. For example 37, first thing I have to do is move this 8m over so I have a 0 on the other side. So I'm going to add it to both sides. So I get 28m squared plus 8m equals 0. Factor out the greatest common factor. Greatest common factor between 8 and 28 is going to be 4. The lowest power of m, except I wrote that as a cube, lowest power of m is 1. So divide everything by 4m. 28 divided by 4 is 7. M squared divided by m is m. 8 divided by 4 is 2. M divided by m is 1. Set each factor equal to 0. So this one, m is 0. And this one, subtract 2 from both sides. So 7m is negative 2. Divide by 7. And m is equal to negative 2/7. So again, to solve, you make sure you have all your terms on one side of the equation with a 0 on the right-hand side. And then you factor out the greatest common monomial factor. And then you set each factor equal to 0. One thing I want you to notice is that in each of these I had something squared, and then that's something. I have something squared, and then that's something. I have something squared, and then that's something. Anytime you do that, you're going to end up with one of your factors being 0, and the other factor is going to be based off of what was left over after you pulled out your common monomial factor. Now we're going to do an application type problem using vertical motion model, and I'm going to erase the board and show you the model and work through an example. The vertical motion model is provided in your book. However, I would like you to memorize it in a slightly different format. The way I'd like you to memorize it is that the height at any time t is equal to negative 16t squared plus the initial velocity times time plus the initial height. Okay, so the sub-zeros mean initial, where v is velocity, h is height, and t is time. V is velocity, h is height, and t is time. Okay, where this model comes into play is anything that you toss up in the air that will come back down, and this is going to allow us to figure out when an object is going to hit the ground, assuming that it started on the ground. For example, if you have a grasshopper that jumps from the ground with an initial velocity of 32 feet per second. Okay, one thing I want to tell you about that this model is in feet per second. We have a different model if it's in meters per second. I want to know how long until it hits the ground. So what I'm going to do is I'm going to substitute in for the information that I know. So I know the initial height is 0. So that term is going to go away. And I end up with the following equation. Negative 16 t squared plus the initial velocity times time. And I want to know when its height is 0, because that's where the ground is. So I'm going to factor out the greatest common monomial factor. Greatest common factor between negative 16 and 32 is, I'm going to pull out a negative 16. Lowest power of t that appears in both of them is 1. Divide each term by negative 16t. Negative 16 divided by negative 16 is a positive 1. T squared divided by t is t. 32 divided by negative 16 is negative 2. And t over t is 1. Set each of these factors equal to 0, and I get negative 16t is 0. And t minus 2 is 0. Therefore, t is 0, which we knew it was on the ground at time 0. And then add 2 to both sides, I get t equals 2. So the grasshopper will hit the ground at 2 seconds after he jumps with that initial velocity. If you want the vertical motion model in meters per second, it's negative 4.9 t squared plus initial velocity times time plus initial height. So the top one is in feet per second, and the bottom one is in meters per second. I'll put feet per second up there. You need to know these two models. You will see them on probably the Smarter Balance tests, the SAT test, and definitely you will see probably the top model on homework, quizzes, and tests for this chapter. Last thing will be the 2 example problems, and that'll be it for the video. So the 2 problems that you're going to turn in at the beginning of class after this video are guided practice number 5 that says solve 4x squared equals 2x. And the second one is guided practice number 6. How long for an object to land if it jumps straight up with an initial velocity of 12 feet per second? So again, 4x squared equals 2x. Solve that one. And using the vertical motion model, how long for the object to land if it jumps straight up with an initial velocity of 12 feet per second?